The next 3D window option is Campbell diagram, which is to display the amplitude of all major PSD peaks as function of RPM and frequency. Campbell diagram is a special case of scatter diagram with Y window default to RPM and PSD amplitude represented by symbol, or circle, size. The first step is to import the desired RPM data into Y window. Let's use the current Y window data, which is RPM N1. Then click the Campbell button to show its menu, which is the same as the scatter diagram menu. First specify the minimum signal-to-noise ratio of qualified PSD peak. Then enter the number of frequency bins around each PSD peak for its RMS calculation. Also specify the minimum frequency separation between any two adjacent PSD peaks so that any local peaks can be avoided. Now click OK. A new 3D scatter diagram will pop up. Each circle here represents a major PSD peak extracted from the 3D window. Its x-axis represents the Y window data, RPM N1. Y-axis represents the frequency of PSD peaks. Z-axis represents the amplitude of PSD peaks, which is indicated by the size of the circle. The Campbell diagram is also overlay with sync/harmonics lines such as 1N, 2N, 3N and so on. From such 3D Campbell diagram, it is very easy to identify any spectral component whose frequency is proportional to RPM, such as this 12N, 18N. Any other component whose frequency is not proportional to RPM can also be easily identified, such as this strong component around 5N.